From hostile deserts to lonely islands and the highest mountains, wherever there is space to expand into, human do so. So it's hardly surprising that we are already making preparations to set foot on Mars, and to create the first permanent colony outside of Earth, maybe even terraform another planet and turn it into a second blue home. But wait, before we get into the nice future stuff, we first have to complete the second step of colonization, creating a semi-permanent outpost. To prepare the ground for larger human presence, but doing so will be hard. Hello and welcome, my name is Samyadeep and today I am going to talk about my idea of Space Dome. Now, what is this Space Dome? Space Dome is an 3D printed structure which is made for the living of the astronauts in outer space. Current it is designed for Mars, but in the future we can modify it for other planets. Now when we talk about Mars, we think of a cold, radioactive desert where the ground is poisonous and breathing is impossible. Mars is awful, so we need something to protect our astronaut from these types of condition. So we need something to be more robust, strong, affordable, and easy to manufacture. This is where Space Dome comes in. Now let's solve all the problems step by step. The first major challenge for our Space Dome is Mars is energy poor because of the distance of the Sun from Mars. Solar power is only as 40% as effective as here on Earth, but even this weakened sunlight is often obscured of days by enormous dust storms. Solar power alone would probably not be enough. Alternatives such as wind power and geothermal energy are also unfeasible, as there is hardly any atmosphere and Mars' interior is much too cold, so we are going to use hydrogen fuel cells at a more cheap cost. We need air in our Space Dome, so we need to pump in oxygen and nitrogen, so we need, which comes with much more problems, as the walls of the Space Domes must be rounded and strong enough to handle the pressure differences. Luckily, the Space Dome will be made up of small triangles locked together in a hemisphere-like shape with several layers of Ninja Flix PLA to make it strong enough to keep our astronauts safe. Without a dense atmosphere, half of all radiation coming from space reaches the ground. An astronaut on the surface will be subject to 50 times the radiations that there would be on Earth. 3 years on the surface of Mars exceeds the radiation dose limits imposed on astronauts for their entire life. This increases cancer risk significantly. To prevent that, we have to shield our Space Dome with a thick layer of dry ice. Covering the ice with a plastered layer of dirt will further increase the level of protection, and there it's done. Our Space Dome is completed. The inner layer of triangles and the Ninja Flex layer will be 3D printed. We don't have to carry anything from Earth other than 3D printers and Ninja Flex filament, which is affordable and light. After the 3D printed layer, the next layer will be made up of Peltier modules, which will keep the inner of the Space Dome warm and the outer will be cold, so that the frozen CO2 layer doesn't evaporate off, and the next layer will just be plaster from Martian dust. So there you have it, a more affordable, reliable, strong, and easy to manufacture option. At last, thank you for this opportunity and hope you will find my idea useful.